Hello, everyone. D. Alfred Ostrowski here, and in this recording, I'm going to give a short tutorial demonstration of a Golang microservices REST-based application that's going to do a simple read and write to a stationary JSON file. And of course, this could be extended very easily to any type of data source, including document-oriented database or relational database, or any other type of data store. I'm going to be doing this on an Amazon EC2 instance, and I'm going to be starting from scratch with no prior knowledge or information other than being able to procure an Amazon account and a PPK key. So let's get started. Right here, I am in the Amazon console, and I was just going to go right back to the EC2 instances. And if you are not familiar with EC2, you can just simply search on EC2 to get there. So I'm going to click on the upper left to get to the instances. I'm going to start a completely fresh instance, do the installs and everything. And all the software being used is going to be documented on a GitHub, and I'll be associating that with the video. So here I'm going to do a launch instance. And here I'm going to instantiate a Ubuntu instance server 2204, and I'm going to use a 2.2 micro. I don't need a lot of resources to be able to do this particular example. And I've already generated a PPK key that will allow me to connect to my instance, and everything else I'm going to default. So I just launched that instance. This will be up really quick. And it already generated an IP, so now we can log into that instance. I have a copy of Putty, which is a tried and true client to gain access to Unix instance. Make sure I got my authorization key. I set my connection up to a 30-second interval to avoid timeouts, and I'm going to bump up the font to make it a little bit easier to read. This looks good. I don't have any passwords, just use the default Ubuntu, and I'm into my instance. So I'm going to do a quick and dirty demo. I'm not going to create a separate directory. I started from scratch. So I'm going to pull in a couple files from my GitHub. And again, I'm going to make that available so you don't have to worry about getting the details from the recording. This is a one-file application, and I'm going to put it in a file named main.go. Had an oddball character here I just deleted. So let me run through the code. There's not a lot of code here, so we can go through it pretty quickly. So I have an earlier example where I did a basic routing based microservices example, kind of a hello world of routing. That should be available on the YouTube as well. Here I extended that a little bit to read and write to a JSON file. I'm using your standard, as I did in the prior example, format and net HTTP. If you want even a more basic example, you might want to look at that recording as well. I'm using the Gorilla Mux library for additional support with regards to routing. And then the next three libraries I'm importing are going to allow me to read and write to a JSON formatted text file using IO, IOUtil, OS, and encoding JSON. The next structure is a Golang structure defining an ID, name, description, price available, type record, or JSON-based data structure. Two handlers are going to be served by this Golang web server. First is allow me to read in file under a subdirectory called data. It is going to be called data.json. Do a test whether it read in the file appropriately, otherwise it'll generate an error. Once it's read it in, it's going to send a header command to respond to either some type of GET request, either from a command line curl utility, or I could use Postman. In this case, I'm just going to use a basic web browser, which is going to allow me to accomplish the same thing. So here it's going to write it out the header and then write the data appropriately. And that's all that it's doing. The next function that's going to be served on this web server is going to read in a body of the request. In this case, I'm going to be relying on a post command. For those of you not familiar with REST style programming, it's just basic bare bones formatting that your web browser is already accomplishing for you. So in this case, we're going to be sending an update record to the JSON format, and that'll be stored in the request object and accessed by r.body using the read all command in the IO utility library. I'm going to do a test to see whether it is formatted appropriately. If not, it'll generate the appropriate error. It's also going to check if that data is in the appropriate JSON format. If not, it will also send an invalid data format error. Following that, it is going to read in all the data from the file to support and then append to that file format. Again, some error checking here. And also, in this case, taking JSON data and loading it to memory into an array of products. So each line of the JSON records will be stored as an array. Following, we're going to append product to products, product being the body of that post command that's going to be sent. It's going to write it to the JSON file and then do a write back to that text-based JSON file with the appropriate error checking, then sending a message back to the request saying it's added the new product. Both of these functions or methods, if you will, are going to be managed by the MUX router. And if you can note here, we're not sending any parameters with the routing. It's all the base route, but it's distinguished from each other by whether you're doing a get or post command appropriately. Now, again, your web browser typically manages the post commands behind the scenes. It's hard to make for the user to see that it's not transparent. But however, we're going to be using the Postman utility to emulate what the browser is doing and avoiding having to build a complete application. I'm going to serve this on port 9090 and set up a starting message and wait for any types of requests. And that's basically the entire application right there. Now I'm going to make a directory called data. This is going to store the data.json data, which again, I have as stored in the GitHub. So I can just cut and paste this right in. This is following the same format as the record data. And you can see some of the updates in earlier tests that are written to that file. Now I'm going to go back and I'm, in this case, from the main directory. I'm going to load in some of the extra software that we need to accomplish this. And again, these commands you should be able to cut and paste. If you're using this exact instance, you can cut and paste it and run it exactly the same fashion that I'm doing it right now. First, I'm going to run sudo app get update. That's going to perform the appropriate updates to load in the following Golang as well as GorillaMux libraries. I'm going to run Golang now. Eventually may be interested in running this application or an extension of it within a container, which case you will not have to build your own Golang environment. But we don't have that right now. We're running a simplified version, so we need Golang to get that server up and running. So that should install pretty quickly. Next, I'm going to do a go mod init and create my configuration files to run the go dot mod file. And I'm going to use go mod init and then go mod tidy. This configures the file appropriately to the software that's needed. And then the final installs, I'm going to install the GorillaMux library to support the routing, sudo apt install. Sudo is the catch-all. It's going to give you admin privilege, and it's typically used in the case of the Ubuntu environment to make sure that everything installs appropriately. So I have my data, I have my microservice application all rolled into a single file. I've generated the go.mod file and sum file by using the go mod init and tidy. I should be good to go. So let's give it a try. Do go run main.go. Start on my server. Now, one thing I need to do before I access that is check my security and make sure that I have privileges to access that server from the client. So I'm going to access the security group. And edit inbound roles. Once I'm in inbound roles, you see I have secure shell. Well, I need to allow a greater means of access. So I'm going to set to all traffic. That's going to shotgun a little bit and IP4 appropriately. So I set up my security group. Otherwise, you're going to get a 404 error in most cases that you're not going to be able to have automatic access to that instance from an unknown client or somewhere on the internet. I'll go back to instances. In this case, under details, I'm going to grab that DNS, and we should be able to test that get command. I'm going to use a simple browser to accomplish that. So bring up Chrome and bring in my DNS, and remember I'm at port 9090. So let's pull that in. And there you have it. That's my input file that has been responded through the GET request that is generated from my, it's basically using the browser. Let's try a post command. In this case, I'm going to use a postman utility. So postman, I'll put a link up on the GitHub to direct you where you can get access to it. Should be easy to find. It is a free open source utility to perform testing for REST applications and a number of different types of full stack or cloud-based applications. In this case, I'm going to pull in that DNS. You see, I already have the JSON formatted in. This is the body that's going to be sent. I'm going to slightly modify that and see if it updates that file appropriately. So I can do a post and subsequent get and test that file. So I'm going to copy my updated DNS, port 9090, and I have body selected here, and I have JSON selected here. Here I have some JSON, and you can grab that from the data file, just pull a record out, and let's modify it to have a unique record that I can write to my data collection. I'm going to add all sevens. And in the name, I'm just going to call this my last test. And I can set the price to a different number as well. Just set some 2s and let's do the send. So did sending, responded with added new product as defined. So now I can bring up my browser again, the inset, and let's do another get command. If you see here, 7's my last test right here on the bottom. So I was able to use a Golang-based microservices application, read my JSON file through the get command, and update it through the Postman utility, and subsequently run the get again to validate that update. And there you have it. So this can be easily extended to any other data sources, as I mentioned earlier. It's a good starting point from your basic Hello World application to seeing how you can leverage Golang-based microservices to support greater utility in your application. So thanks for listening. And again, all the resources will be directed to after below the video. And good luck with it. Thanks again. Talk to you soon. Bye now.